Hi, this is Nalini Elkins with Industry Network Technology Council. Welcome to the part 2 of our getting started with IPv6 on the mainframe. If you're here, then I assume you know what you're getting into because you've seen part 1. So these webinars are a set of collaborative efforts with the India Internet Engineering Society and Industry Network Technology Council, both of whom are nonprofit organizations. And we have had funding in the past from APNIC and Aaron, the Internet Registries for Asia Pacific and North America. And we thank them very much for that. So our vision is to help you, the large enterprises, with IPv6 deployment. And to that end, we're doing training and a deep dive into security and application version. And then we'll also help you plan. So do contact us. We do have people contacting us to have us comment on things like their address plan, various questions that they have. And our team is very happy to help you do that. So today we are doing part 2 of IPv6 on the mainframe, and that will be followed in December by IPv6 and 5G deployments. I'm very excited about that as well. Next year, we will have 2022, we'll be focusing to a great extent on IoT, DNS, DHCP, all those kinds of things. If you have case studies, if your organization is deploying IPv6 and you would care to do a case study, we'd be very happy to have that. Please contact us. As you know, these webinars are being recorded, but just so that I say that again. I'm going to just leave this for you. I think that's plenty about me. And so let's talk about Rob a little bit. Rob Hamilton is kind enough to do these 2 webinars on ZOS. And it's ZOS is a very particular specialty, as I'm sure you guys all know, but it is the backbone of many, many, many corporate networks. And Rob has a great deal of experience in this. He has deployed IPv6 on the mainframe, on multiple mainframes, and so no one better than him to give you a head start on how to go about this. So without any further ado, I'm going to turn it over to Rob. Thank you so much. Let's see if I can make you presenter now.
Okay. Can you see? Let me start this guy up here. Can you see that?
Yep. Yeah.
I hope so. Oh, that's good. Okay, let me minimize this guy over here. Once again, this is the second part of talking about how to implement IPv6 onto your ZOS systems to begin with. Once again. All right. I'm with CAS. Just so you know who we are a lot of people, and I really hate the thought, but we're like a Google for chemists. What we do is we ingest all of the open chemical literature that's out there. We have a catalog of over 250 million chemical substances, including well over 1 billion chemical reactions. We have the ability for you to search those reactions or to even to do structure searches based on the chemical structures that you're seeing. One of the important things right now for us, not just for us, but for everybody in the world, is talking about diseases. And so we work with pharmacology folks and chemists in order to investigate what's going on with those. This is our webpage, our home webpage on the internet. And this right down here, this is the important one right now. We have all of the research on COVID-19, and this is not the first time we've had to do something just like this. COVID-19 is it's a SARS-based virus, so even as far back as when we had problems with SARS, when we had problems with MRSA, and those sorts of things, we were the resource that people used in order to get information about how they can fight these diseases. So that, frankly, is pretty much what we're doing. Sorry, let me get back to that. So that's what we provide. We provide information about chemistry and medicine, and as you can see here, DNA and RNA sequences even. So we work not only with chemical companies, pharmacology companies, and in fact, we provide information to various, police and fire department forensic groups. So they know what it is they are looking at. So that's just a little about us. Basically, back to what we were really wanting to talk about. This is the second half of our discussion about the implementation of IPv6 on ZOS. Just a couple of things to go with that. Some, disclaimers are always important. I did this it's been over 10 years since I implemented IPv6, or at least since I started it. These are the steps that I took then. TCP/IP has evolved in ZOS since then, and so some things, and I'll try to point out where things have changed, but by and large, what I have here is a description of what I did back then in 2008 to 2012 in order to get IPv6 going. Your network probably is going to be different from mine. I run a small ZOS. That's in quotes. We have a small ZOS system, actually 4 ZOS LPARs, a couple of ZVM LPARs, a couple of Linux guests on those. But ZVM, or ZOS rather, is an important cog in the machine here as far as being able to search those chemistry databases. And so it was important to me to get IPv6 installed so that, if there are folks attempting to talk to us with IPv6, they can talk directly into our system, and I'm happy to support them. So these steps that I'm giving you, again, this is either going to get IPv6 implemented for you or get you well along on your migration trip there. But I will say that your mileage may vary. And usual disclaimer, all the IP addresses here that aren't publicly available have been changed along with the names of other configurable items and hardware, blah, blah, blah. That's the normal stuff. One thing I will remind you of right here is that I use to use its full name, the ZOS Communication Server IPv6 Network and Application Design Guide. That guide is very important. It provides virtually everything that you need to know, outside of what I tell you, of course, in order to get IPv6 implemented and working well on your system. Not only about configuring the system itself for IPv6, but also when it comes to migrating your applications. So important tool for you to use. So first time, a couple of weeks ago, we talked about how to taking these steps, planning your implementation, making sure you know what kind of stack you're working with, and at least starting with something small so that you can so that you don't hurt anybody along the way. Enabling IPv6 sockets, IPv6, or rather all socketry is handled by OMBS, and so we have to make some configuration changes into OMBS, which is controlled by the BPX Parms guy and ParmLab. We also enabled that communication by making a one-line change into your TCP/IP profile. So we covered that, and then we talked about name and address resolution, configuring your resolver in order to allow you to look up IPv6 names and addresses along with IPv4 names and addresses. So that's what we talked about last time. Here's what's left. We're actually going to configure your profile for TCP/IP to configure those communication components, whether we're talking configuring your OSAs, configuring hypersockets interfaces, some primary and application VIPAs, which I use all the time. Some other folks may not use them. Not the dynamic VIPAs. This is just regular static VIPAs that we use. And then we'll talk about the IP side of Enterprise Extender. That will take a bit of time, just because it's a lot of fun, but it's actually a little bit complicated. And then we'll talk about configuring IPv4 and IPv6 routing, just so you're able to get from your system to anybody else. Now, to start with on these communication components, there are 13 statements, and I get that from the Network and Applications On Guide. There are 13 statements you can use in your TCP/IP profile for configuring IPv6. A lot of them start with the letters VIPA. I didn't use any of those. I actually only needed 3, and that was IPconfig6, the interface statement, which actually configures your communications interfaces, and then the routing table setup, which you do now with begin routes and end routes. We talked about IPconfig6, and we talked about enabling the IPv6 sockets on your system. Once you put IPv6, or I'm sorry, once you put IPconfig6 with a couple of his parameters into your TCP/IP profile, then you can start using IPv6 for communicating between applications on a single system. We still have to add in the ability for you to talk to other systems, and so that's what we're going to do next. Now, when you're talking about IPv4, we always use this device, link, and home. If you've done TCP/IP configuration before, you're familiar with those. Yeah, I'll just say that. And then the device name is what you specify on a start statement, but this is what those statements basically look like. You got a device, you have a link. I don't know if this device name is supposed to match this or if there's something else that this matches, but this is IPA QENet is your link type. That's the guy that really matters here. That's what decides that we're actually using or configuring an OSA here. And then of course we put your IP address down here under the home statement. That's what it looks like for IPv4. Now for IPv6, we just use this interface statement. The good thing about it is that it covers everything, okay? We'll give you an interface name, but the port name specification that connects you to the VTM TRLE for talking with that particular and deciding which OSA you're talking to. The IP addresses can be included in an interface statement. You can in fact put multiple interface statements so that you can configure multiple IP addresses if you like. If you're doing hypersockets, you can specify the chiplet in the interface statement, and then other IP characteristics like I always use the source VIP int. We're using SMCD, but I specify SMCD on the global configuration statement, so I don't put it on these guys. So basically, what we have this nice shiny interface statement that you see right here. Okay, this is the port name that identifies, again, connects us with the VTM TRLE. I'm going to turn on my laser here for a second. That's what this guy here specifies. I much prefer having this. Here's an entity, and here's what its value is. The IP address. Here's how we specify the IP address, so I don't have to. We can't include it in the home table. Here's how we identify the IP address that we're going to use to talk with this particular OSA. This interface name is the interface name. It's the name that you use when you do a start or a stop or if you want to inquire against an interface. Down here, you would use the interface name. Up here, we use the device name for doing that. So it's inconsistent, but that's okay. But yeah, that's okay. This guy right here again says we're using an OSA. IPAQENet is the link type here, and the interface type down here, IPAQENet 6. We always add the 6 on the end for whatever reason. This VIPA right here is the guy I'm going to use to ensure that all traffic going out on my OSAs uses a consistent IP address. So I can specify other parameters down here, but this is the basic configuration. This is a basic statement that you need in order to configure an OSA to handle IPv6 traffic. Okay. Now, what's really nice is that for IPv4, you can use this shiny statement that looks a lot like that. He's got a different interface name. That's okay. We specify the same port name. For the IP address, we actually include the CIDR specification right here. I do have a different source VIP interface guide because this is IPv4, this is IPv6, as you can see by the fact that the 4 is missing up here, okay? So what this means is that both of these guys are going to use the same OSA, okay? And sorry, we're going to use the same OSA for both of these guys. OSA 3, this is how it gets defined over in the VTAM guy, not on my system because I don't have one by that name. But one benefit that this gives you is that TCP/IP, when he finds that you have configured both IPv4 and IPv6 for a particular OSA, then he will segregate the IPv4 and IPv6 traffic. Ordinarily, when you use an OSA, he assigns 3 ports, three sub-channels on that OSA, one for read, one for write, one for data. And if you just had device and link specifying that OSA, then you would use those 3 sub-channels. Even once you defined the IPv6 guy on the same guy, he would use the same data sub-channel for both IPv4 and IPv6. Here, since he finds you've configured both of them using the interface statement, now he knows he can actually segregate all the IPv6 traffic onto a separate data sub-channel from the IPv4 traffic. And personally, I thought that was pretty cool. But it allows you to monitor that traffic differently if you like. So in any case, that's just a freebie for you. And then this interface name, we have just one name associated with it. We don't have to deal with a device name and a link name. We just have these interface names, and that's what you use on the start statement or the stop statement for that particular guy. Let me back up just real quick. Are there any questions about how we define the OSAs into your TCP/IP profile? Once again, this guy has a CIDR specification. This guy doesn't need it. Once I put the IP address up here in my interface specification, I can take it out of my home list. So you shorten up the home list for each interface that you define. So
yeah, I'm not seeing any questions, guys. If you have any questions or you want to say anything, please, you can raise your hand or you can type the question into the panel. Are so good, Rob. I'm not seeing any questions.
Okay.
Mike.
Hey, Rob. Mike. This is Mike. Can I ask a quick question on the OSA definition?
Absolutely.
And yeah, you talked about how V6 and V4 traffic are separated into different sub-channels.
Right.
And it sounds like you think that's a good thing. Is that so like that when you're doing monitoring or diagnostics, you can kind of look at them and there's some tag to tell you which is which? Is that why it's good, or why is that a good thing?
I like it because, yeah, you can monitor an individual device if you like. Now, let me back up just a little bit. When I define my the TRL for my OSAs, I define like 16 ports for each OSA. Now, obviously, using this guy right here takes 3. This guy here, takes just an extra 1, so that's 4. But if you're going to use something like the OSA Enterprise Network Traffic Analyzer, he's going to take another 4 or 5 or 6. So that traffic gets split out across multiple devices, even though, let's face it, your OSA has 1 cable going into it, but really as far as MVS is concerned and VTAM is concerned, you can observe that traffic separately if you choose.
Okay, and that makes sense. Now, and so that would make sense to ZOS. If you're looking at sort of a generic packet trace, is there any tag or information where you can see that same separation information?
No, I don't believe so. And the reason I don't think so is because that would be talking with TCP/IP directly, whereas VTAM is the guy actually handling the IO to the OSA. So that's a connection between TCP/IP and VTAM, but your packet trace is going to see what TCP/IP tells them.
Okay, great, good answers, great info. Thank you, Rob.
Okay. So what I'll do next is talk about hypersockets. Hypersockets are very similar. They look an awful lot like OSAs. Once again, we use device and link to configure that for IPv4 if we always have. But we add this interface statement here. One of the really good things I like about it is that the chiplet is specified with the chiplet tag, as opposed to up here where it's sort of incognito. Down here, we actually say specifically which chiplet we're actually going to be using for hypersockets communications. Once again, IPA-QIDIO is the link type up here. Down here, IPA-QIDIO 6. Okay, so we add the 6 on the end for that. That's how we know. This guy here, once again, he's got his IP address specified here, and I actually again use source BIP interface for the sockets or for hypersockets as well. One of the things that I think is very interesting is that the actual protocol name is IQDIO, not QIDIO. So I figure, yeah, maybe there's, instead of having a 4 missing here on the end, maybe there's a T missing on the end or something. But once again, this is just how you would configure your hypersockets connection right here. And then you would start this interface name right here. I have my interface name HS17 Ethernet 6 for that guy. Once again, thank heavens, for hypersockets, you can use the interface statement to configure the IPv4 communications. You specify, hey, the chip is specified on a chiplet tag, imagine that. IP address, again, with the CIDR specification, there's a different VIPA associated because this is v4 and this is v6. So this, as far as I'm concerned, again, simplifies the configuration a bit for your hypersockets connections. Once again, once I specify the IP address up here, I can take it out of my home list. I'm not using device and link. I don't need the home list. That's pretty easy. At least it's pretty easy for me. So I will take any questions on that as we get there too. Primary VIPAs, and again, what this does is to using source VIPA interface, what it does is it allows you to specify that for outbound traffic, any OSA, and I have multiple OSAs for each of my IP stacks. Again, I have 4 ZOS systems and I have 2 IP stacks on each system. So traffic coming out, I want always to have the same source IP address. And that's really what this guy does right here. Virtual for IPv4, virtual 6 for IPv6. This guy does not require the CIDR specification. We're just specifying a host name or a host here, and so we don't need it there. Once again, the IPv6 address down here. These two guys, and I have this included. These are comments directly out of my profile for TCP/IP. These two VIPAs have to be configured first before you configure an OSA or hypersockets to reference these guys. Otherwise, he won't configure your OSA for you, and you'll be stuck. You have to go back and sort of reboot or retry. Let me think there. Yep. Once again, no CIDR spec here for this guy, whereas we need it for the other guys. Now, once we've done these, we also, for some applications, I know at my place I do this a lot because I have multiple applications all listening on port 23, and in order for them to do that, they each listen on a different IP address. So we specify an application VIPA in order to specify that we've got another IP address that we want traffic for on this ZOS system. I do the same for IPv6. Very straightforward as far as setting up for my applications. As I migrate the applications to use IPv6, I added this guy in there and gave him the IP address here. And then of course, specified this IP address in my Etsy IP nodes file with the name that I really wanted to give for my application. Any questions on that so far? Again, this is fairly straightforward stuff.
Yeah, Rob, I've got a question.
Absolutely.
Yeah, no, this is super interesting because I'm just trying to think at the socket level. You know what I mean? It's like if I'm writing an application program, I just, because like, okay, if you're writing a socket program, say for like Windows or something like that, I believe you can do like in-add or any, which means you're listening on anything on that interface. But it sounds like, and I need to go back and look at in-add or any, but you know what I'm saying? It's like, it sounds like you're talking very specifically. I mean, I wonder, I'm just thinking to myself, how the application is going to get communicated this. You know what I'm saying?
Here's what I think you're talking about. FTP, if you FTP into a system, by and large, FTP is listening on in-add or any, which is for IPv6, that's just 128 0 bits, and in that case, it doesn't matter which IP address, which destination IP address someone gave on that incoming packet. It's going to make it into FTP because he's listening on the right port. In this particular instance, what I have is my application is listening on a, well, as it happens, he's listening on port 23, which is the telnet port. And I've got multiple, like 15 different applications running, all listening on that telnet port. So in order for the traffic to get specifically to one of those guys, they need to be listening on a separate IP address. So what this does is this basically configures an IP address that then gets stored into the OSA, so the OSA knows where to pass that to. But this IP address plus that incoming request for port 23 choose the application. The application itself is listening on this IP address and port 23 in order for him to handle that specific incoming traffic.
Right. So that's a specialized application that's listening on multiple IP addresses. I mean, and it could be multiple ports too. I mean, you just chose port 23. It could
Right.
be port 9000, whatever.
Right.
But that particular,
my
yeah.
particular application prefers listening onto the telnet port because it is actually a telnet server front end to something else. And since I have many instances of that running on each LPAR, I actually have multiple IP addresses so that that traffic then is segregated by the IP address into the specific instance of the application that I want.
Sure. No, makes a lot of sense. Thank you.
Sure. And it was running that way before I got here, so thank you. It's not my problem. So that's basically how to configure most of the stuff that you're going to need, at least as far as allowing applications on multiple ZOS systems to talk to each other using IPv6. Now the next thing here is Enterprise Extender. One of the features in ZOS, once again, VTM is handling all the IO on the back end for him. If I have multiple IP stacks on the same LPAR, on the same ZOS system, okay, and I want, say application 1 on IP stack TCP/J wants to talk with a method application APPZ on IP stack TCP/7, where those two IP stacks are on the same ZOS system. The way to allow them to talk to each other is to define this same host device. IET same host is basically a VTM construct that allows two IP stacks to talk to each other without having to go anywhere, if you will, outside of the ZOS system. You configure an IET same host guy on each IP stack, define it with appropriate IP addresses and so on and so forth, and that allows them to talk to each other. Well, that's great. Then, of course, IBM in their wisdom says, we're going to use that same guy with this same internal connection into VTM for Enterprise Extender. So Enterprise Extender uses this, and what Enterprise Extender is it allows for encapsulation of SNA traffic inside IP traffic. So basically you have IP headers and the like in front of an SNA packet, and that's what you're sending because we want to allow SNA to communicate across the internet. And since we can't really convince too very many ISPs to route SNA traffic, we'll let them continue routing IP traffic and just not tell them that what the actual traffic is SNA traffic. So that's kind of what we do. We have a connection to a business partner across the lake that that we support using Enterprise Extender. We have SNA on both ends. We have an SNA application that has worked for a very long time, and we're not going to be replacing anytime soon. So this allows those two guys to communicate via SNA on an IP backbone. So that's what Enterprise Extender does for you. So now back when I configured this, all right, we configure the IPv4 side with a device and a link. And for the IPv6 guy, we have to have a VIPA defined, and then we define an interface again, the same TRLE name here, IAT same host as we're specifying up here, or I think it's actually over here. But this allows us to then configure, this actually enables enterprise extender traffic over IPv6, okay? This is the IP side of that. There's still some work that has to be done on the BTAM side. And of course, if you've already done it for enterprise extender already for IPv4, all you really have to do is to make really just a couple of changes. Okay, wait, let's take a look here. ISD-TRL is the Dynamic Transport Resource List. That's what TRL stands for. And so these are all the TRLs associated, TRLEs associated with communications for TCP/IP. As it happens, these ISM guys, this is all SMC traffic, and so this guy supports SMCD for my OSAs on one system. This does it for a different stack. This supports supports hypersockets. And then these MPC guys are actually the hypersockets links. So this is why we say, hey, we've got chipped, say, Delta 3 here, handling hypersockets for one of my IP stacks. And you can see that I have two for that Delta 3 guy, and that is because one of these is handling IPv6 traffic and one is handling IPv4 traffic. I'll let you guess which is which. And you can see down here, I've got another hypersockets network, Delta 5, and he's got, again, both IPv6 and IPv4 TRLEs defined. Here's two more hypersockets networks as well. Whenever you start hypersockets, he automatically creates this guy. You'll notice that he's never been activated, at least not ever that I have seen has this particular guy been activated, but he's just sort of the basic TRLE for talking with hypersockets. That guy always shows up. And then this is the IAT same host guy that we were just talking about. This is where the traffic is actually handled or redirected, if you will, from TCP/IP. Actually specifies this as his his communications port, if you will. Now let's take a look at what IAT same host actually has, and you can see once again these two. This is for two different IP stacks, and this is so again. Traffic between those two IP stacks, so that two IP stacks on the same system can talk to each other. Those aren't my IP stacks, but that's okay. They really are IP stacks. That's what those are for. And then there's these four guys in the middle, and that is the enterprise extender external communications adapter connections. Okay, and you'll see there's four of them. The reason there's four of them, I guess. Okay, here's why there's four of them. I have this for IPv4, this for IPv6, that's IPv4, that's IPv6. These two guys handle internal traffic between LPARs in my over hypersockets. These guys handle enterprise extender traffic over the OSAs out to the rest of the world, or at least out to the rest of our network. You can tell that these are fake numbers because, hey, nobody uses these numbers. What's that about? But these guys here, you will see that they have different group names. This is BTAM. This is probably a little out of our neighborhood here right at the moment, but when you want to configure enterprise extender to support IPv6 over on the BTAM side, that's another hour-long presentation, but just to say, you need separate group names associated with separate, you actually specify the IP host name to BTAM. Get used to specifying IPv, or get used to specifying IP host names to BTAM in your BTAM configuration. But that was just the fun part of trying to get those guys configured. Before I go on, any questions about the enterprise extender guy? This is probably the more complicated piece of the actual network configuration. So I thought I'd stop and give you a second.
No, I'm not seeing questions, but for sure, enterprise extender is very, very complicated. And I think the bottom line is what you said in the very beginning. You've got some very old, but very stable and highly used applications that are still using SNA. And it's like, you know, basically, if it ain't broke, don't fix it, right? I mean, you're not going to be rewriting this anytime soon. Am I hearing you there, Rob?
Absolutely, we're not going to be rewriting that ever unless somebody drops support for enterprise extender. But yeah, that's not something. Recently, we expanded it to use multiple links instead of just one communication link. Now he supports 10, but it's all on the SNA side, not on the IP side. So I'm pretty sure we're not going to be changing that again anytime in my lifetime. So
Sure, thank you.
one of the things about this, I'm gonna back up real quick to this configuration. This, once again, this was how I configured it about 2013, 2014 was the time frame, okay? This was how I was told I had to configure this because, you know, they wanted separate ways of identifying the IPv4 traffic from IPv6. And of course, specifying device and link actually means you have to have a host ID or you need a home specification down lower that includes the IPv4 address for this particular guy. Now, there is an IBM statement of direction, and I heard it, you know, sort of as an aside, but IBM says that they're no longer going to support device link and home for configuration. Now, I have in the past configured this with interface instead of device link and home, but I don't know how well it worked. Basically, that device link at home guy is going to go away, and so you're not going to have to convert everything to use interface regardless. Even if you're sticking just with IPv4, you're going to have to change those to interface specifications. I have no target date to pass you on that. I'm guessing it's probably not going to be before ZOS v2 R7. But as I say, forewarned makes the incoming forearm not hurt so much, okay? So I think you should probably plan to be changing your devices and links to interfaces. Since this guy, again, requires a home specification, all of my IP stack profiles now have just one address in the home list, and that is the guy for enterprise extender. So those stacks where I do not use enterprise extender or IoT same host at all, and I have a couple of stacks that cannot. So just recently I changed their device link and home to use interface, and now the home list is entirely gone from those profiles. So that's just something that's coming down the road. And I say that because now we want to talk about routing. And something I didn't know, because again, I've been using IPv6 since ZOS v1 R13, I think. And once you start using the interface statement to configure an OSA or hypersockets or anything, frankly, then you have to use begin routes and end routes in order to configure your routing table. Well, as it happens in ZOS version 2 release 2, I didn't know this because I didn't have to worry about it. the support for the gateway statement is gone. So gateway you can use only if you're using device link and home, which you can use only if you're defining just IPv4. So one way or another, you've already moved away from the gateway statement into using begin routes and end routes, which is a great thing on ZOS. Gateway is still supported over on the ZVM side. Frankly, I think that's okay because gateway it had nicer syntax on the ZVM side, and they just updated it just a little bit to support IPv6, and so they're good over there. But in ZOS, here's kind of what the gateway syntax looked like. Okay, you would have to specify a network, and here's an odd-looking subnet mask. Of course, here's your link name, and here's the subnet value. The best I can tell with a long lens here, looking back 10 years, is that this really was a subnet route for 172.17.100. Made those numbers up, but I didn't know that at the time, and so when I went and defined this same thing in with begin routes, I actually defined it as a network route instead of a subnet route. Not a big deal. No one was hurt. No photons were modified by this. You can see that you specify the IPv4 address with the CIDR specification. No subnet masks. Thank you very much. Down here, we actually, for IPv6, we also use the CIDR specification. This is, for me, a much easier way of building a routing table. Now, because I used a communications restricted, if you will, IP stack to do my initial setup and testing for IPv6, I had kind of a problem when I specified these default routes. Again, the socketry is all handled by OMVS. OMVS is the guy that keeps the route table. And so if you just say in TSO, hey, I want to FTP to some site, he has to figure out the stack to which you get affinity in order for you to be able to reach that site. And if you have default routing specified for your connectivity restricted stack, it is possible for OMVS to route your communications to this IP stack that can't actually get you to the site you want to reach. There's an IBM APAR about this. I went and looked it up just recently, and it looks like it's been deleted. But in short, well, actually, I guess it's not very short. That's what happens when you, since OMVS is handling the routing table and he has to figure out where to send you, he matches your IP address against his routing table, and he comes up with default routes that are assigned to both stacks, and he will simply toss a coin to decide which default route he's going to use. And so it's possible for him to pick the default route to your connectivity restricted stack. So that's why you can see these guys here are all commented out. This particular stack cannot reach anywhere except he's got one subnet that I don't think there's actually anything on except me. So if I specify default routes to go to that guy, boy, am I in trouble. This particular connectivity restricted stack does not specify default routes, but this is how you would specify a default route, not just for IPv4, but you can specify this with the first hop for IPv6 as well, and specify, of course, different link names. And of course, now, just like on the interface statement, this actually allows you to specify using, here's a tag and here's a value for the MTU size. These sizes are old. You'll notice that, yes, there's a difference of 8 between the IPv4 and the IPv6 MTU sizes. For whatever reason, I'm sure Nalini can tell you the answer to this one, why that's 8 bytes different. I think there's an extra packet at the beginning of that. I don't care. I just know that these are different by this. When I say that these are old values, when I look at netstat devlinks now, and I look at these devices, the device specifications, you will find an ACT MTU, which is the actual MTU that he is using for this communication. For IPv4 on my system, I'm using OSA 6S's, Express 6S, something like that, which is just a 1 gigabit OSA. On my system, his actual MTU for IPv4 is 9,000, and for IPv6, 9,008. So I don't know why, even though I specify smaller values for the MTU, and here he picks another number. That's okay. The same is true for hypersockets. I specified 8K, which is the normal MTU size. MTU size for hypersockets is determined by an IODF setting. In my IODF, there's a value that I specify for that, and I give them 16K, and you take half of that, and that's what the MTU specification is for hypersockets. Well, when I did a netstat devlinks just recently to look at the MTU, the actual MTU for hypersockets, it was 57,344 or something like that. I mean, it was some huge number, which I think is kind of cool because, hey, frankly, we're talking between systems here. We don't have to worry about anybody else and any kind of fragmentation on the rest of our home network here. But you know, we're just talking between systems, just between friends here. And for enterprise extender, I believe it actually was 64K. So ZOS kind of picking the defaults that he wants here for that. So any questions about all that good configuration stuff? Basically that, go ahead.
No, this is sounding really good, Rob. Just a little warning about time. We've got about 7 minutes left, just
Excellent.
FYI.
Excellent.
You've
Okay.
got.
Well, this is the part I can go really fast over. Again, my timeline was influenced by the requirements imposed by a stringent change control program here. I could only update one stack at a time. Then I'd have to wait a month or two to make sure that everything worked okay in order for before I could do another stack. There was lots of other stuff to do, and so it took actually some time in order for me to get all of my stacks upgraded. Basically my networking team on this project is, you know, me, and the software development team on this project is also me. So this and the fact that it was kind of a learn as you go, there was a lot of work overlapping on this. There were a couple of primary drivers for me personally. It was, hey, I want to be the first at my company to get IPv6 running on my system, and boy, I beat everybody else by a good 10 years. So I'm pretty happy about that. The other was the other secondary driver. The thing that actually kicked it off at the beginning was that, you know, the Office of Management and Budget came out with this. We need you to convert everything to IPv6, and I said, sure, no problem. I'll be able to support that. So I actually started on this in April of 2008. Started experimenting with enabling the IPv6 sockets on my ZOS systems. By September, I was happy enough with how the things were working that I start working on all the program updates required. So by February of 2012, which is about 3.5 years, I had all the stacks configured to use IPv6. Some stacks I still had, well, in fact, most of the stacks I still had device link and home specified, and so I would have to go back some years later to take those out. My primary ZOS system, we started the configuration changes in 2009, late December 31st of 2009. About 5 weeks later, I fixed up BPX parms, and then it was a year and a half before I got the interfaces added in, get all those IPv6 interfaces added in, and the last change was to my secure stacks on M1 or on my primary system, and that was in February of 2012. And then I went back and changed all those device link and home specifications in August, September timeframe of 2017, when we were starting to talk about Cisco ACI, which you don't want me to talk about. I have a socket management API. As far as the applications go, this guy made all the work simple. And I say simple. I have a good, by the time I start working on the development of this, I had 17 different API calls in there. And that basically encapsulated all the assembler socket calls that I needed to make. Not all of them necessarily, but all the ones that I needed to make. When I started working on this development, there were 17 routines, and by the time I was done, I was up to 24. And the stuff that was added was things like converting IP addresses from internal form to, from presentation form to network form and back and forth, which is basically binary to character and back. There were a couple routines for those and a couple for handling the important get adder info and get name info calls, and freeing some storage that those guys required. So that was most of the changes that I had to make in order to support IPv6 with that socket API. My Telnet server has a front end to a much older product. It took me a couple of years to do that. The important thing was that it really was not IPv6 that made it take 3 years. It actually took me about 6 months to do the IPv6 modifications to it. There were a large number of other changes going on in that product at the same time. And then there's this other gateway product that I also use IPv6 for. It's very like the Telnet server in that they both have subtasks set up to handle. We use give socket, take socket in order to transfer the control over a communications line to a subtask. One guy actually starts a subtask whenever a connection comes in. He passes off the connection to a subtask that's been sitting there waiting, and he starts up another subtask to handle the next guy. The other one actually just starts up all a couple hundred subtasks all at the same time, and then just picks one to pass a communication socket to. So they're a little different in that regard, but by and large, virtually everything else is the same. One guy has to deal with the Telnet protocol. One guy has to deal with our proprietary networking protocol. So, so the IPv6 part, really, by the time I got to working on this gateway, it took me maybe a month. And that was just for handling the fact that I might want to give him an IP host name instead of an IP address in order to tell him which IP address he was supposed to be working with. So again, here's what my timeline kind of looked like. Yeah, it looks like it took 4 years to do the configuration upgrade. That was actually on 7 stacks at the time. It really didn't take all that long. It was just 1 weekend a month, but I might only get 2 or 3 stacks updated in a year just because of our change control and the fact that I was doing a lot of other work at the same time. So it took maybe about 2 years to get all the socket API guys sort of recoded or updated in order to support the additional IPv6 control block, if you will, the larger sock adder structure that you need. It took me a couple of years on this guy, and you'll notice that I did some additional tweakage in here while I started working on this guy. So the entire time spent doing the upgrade, yeah, it looks kind of long. It looks like it's about 5.5 years. It was just me, and this was just stuff I was doing at the time. The enterprise extender stuff, it took me maybe 10 months, and that was because I would, again, only one LPAR at a time I could make this change to, and I actually had to do, well, if you think about it, 4 LPARs, so there's, 6 communication lines between each of them. We're going to double that to 12, adding the IPv6 stuff. That's how long it took, and it really was not too bad once I figured it all out. This guy right over here, this is where I actually went into most of my stacks and took out the device link and home things and replaced them with interfaces for all the IPv4 connections. I did all my stacks except my 2 secure stacks. 2 of my LPARs have secure stacks on them. I just changed those out as it happens at the beginning of October, so a month and a half ago. And that took me no time at all because I was in the middle of working on this particular presentation, and that reminded me of everything that I needed to do there. So I think that's it.
Right.
So here's what we've covered so far. Go ahead.
No, thank you so much, Rob. Yeah, we're running a little tight on time here, so I don't mean to cut you off.
Yep,
I mean,
that's
yeah, you're at the end. Yeah, thank you so much. This is, again, as I say, this is being recorded, and I know people will want to go back and see it over and over again because you've covered so much. So guys, when you get to doing stuff, you'll probably want to see this. And let me just end and say, if you have any questions or anything, please send it to me, and I can forward it to Rob, and we can collaborate. If you have any suggestions for other webinars, anything you'd like for us to cover, we are more than happy to do that. And let me thank you guys for attending, and most of all, let me thank Rob for taking all this time and effort to do everything. And
Rob, this was great. Thank you so much. All us enterprises appreciate it because we're going to need to do this in the next couple of years. Thank you, thank you, thank you.
Sure enough, my pleasure.
All right. Okay. See you guys next time, December 16th.
All righty.
Okay. Bye.
Okay.
Bye.